Hello students, good morning. In second lesson, now we are going to see the chemical properties of boron, chemical as well as physical properties. Okay, first the metallic nature. So for this we have seen a separate video, metallic nature of p block elements. Out of the elements present in the boron family, only the boron is a non-metal, whereas the remaining elements are metals. So boron is the only non-metal in this group. Then reactivity. Compared to the other elements, this boron is less reactive in nature, but it shows higher reactivity when the temperature is high. Generally the boron is less reactive, but it shows higher reactivity when the temperature is high. And nature of its compounds. When boron forms compounds, they will be generally electron deficient. But they are generally electron deficient, and also this compound shows unusual type of covalent bonding. The remaining elements of this boron family shows ionic bonding, whereas only this element, this boron, it shows covalent bonding. And this covalent bonding is due to some reasons that we are going to see next. This already we have seen. Compared to the other elements, the size of boron will be small. So that is the first factor responsible for covalent bonding. Small size and high ionization energy. Boron will be possessing higher ionization energy compared to the remaining elements of the group. That is also responsible for the covalent bonding. Higher ionization energy and similarity in electronegativity with the carbon and hydrogen. The electronegativity of boron is similar with that of carbon and hydrogen. So because of these factors, the boron shows covalent bonding. So what are the factors? Students, this can be asked in compulsory question. What kind of bonding can be found by boron, and what are the factors responsible for it? What are they? Smaller size, high ionization energy, and similarity in electronegativity with the carbon and hydrogen. So because of these factors, covalent bonding is possible. Then formation of metal borides. Hereafter we are going to see the chemical properties. When boron react with metals, remember very clearly, when boron react with metals, the resultant compound will be called as boride. Many metals except alkali metals. Alkali metals will not form borides. Except alkali metals, many of the metals combines with boron and they can form borides. And the general formula of borides is MXBY. So here X and Y represent the number of metal atoms and Y represent the number of boron atoms. So it's a formula MXBY. And the value of X ranging up to 11. The number of metal can be up to 11, whereas the number of boron can be ranging up to 66, or even higher number can be shown by these elements. So many metals except alkali metals, they can form borides with the general formula MXBY. X value ranging up to 11 and Y value ranging up to 66 or higher. An example is given. Combination of chromium metal with boron. Chromium is a metal. When it combines with boron at higher temperature around 1500 Kelvin, at that time we will be getting chromium boride, CrB. So metal when combines with boron, the resultant compound is boride. An example is reaction of chromium with boron is given here. So first chemical property is over, formation of borides. Then second chemical property is reduction of boron trihalides. Halides means we know. Fluorine, chlorine, bromine and iodine are termed as halides. So boron trihalide means boron will be accommodated with 3 halogens molecules. The simplest example is BCl3, boron trichloride. So it is going to be reduced. For reduction we can use a metal and hydrogen. So boron trichloride can be reduced by using a metal assisted by hydrogen. At that time it gives the metal boride. What metal we use here? W means what? Tungsten. So the tungsten metal will be combined with this boron so that BCl3 is reduced. The tungsten வந்து boron trichloride react ஆகிறதுனால tungsten boron சேர்ந்து tungsten boride மாறிடும். BCl3 is reduced. Okay, so from here Cl2 as well as HCl molecules are liberated. Okay, so this is the reduction of boron trihalides. Okay, then next chemical property is formation of hydrides. Okay, hydrides means metals reacting with hydrogen. The resultant compound will be called as hydrides. About hydrides we had a separate concept in 11th standard. The types of hydrides, their physical properties, everything we have seen. Now we are going to see how does boron react with hydrogen and how about the formation of boron hydrides. Okay, boron does not react directly with hydrogen. There will be no reaction of boron with hydrogen directly. Okay, but it can form a variety of hydrides, and the boron hydrides are called as boranes. What's the special name of boron hydride? Borane. It's very important compound. Okay, boron hydrogen சேர்ந்து கிடைக்கிற காம்பவுண்டுக்கு பேரு borane. Okay, then the simplest borane is diborane. So many boranes are available in the out of those boranes. What is the simplest borane? Diborane is the simplest one. Its formula is B2H6. The other larger boranes can be prepared from diboranes. So then whatever borane you need, you can prepare them from what? From this diborane, from B2H6. Okay, so this is the formation of hydride. There will be no formation of hydrides directly. In an indirect way it can be prepared, and the boron hydrides are called as boranes. The simplest borane is diborane and its formula is B2H6, and the required other boranes can be prepared from diborane. Okay, here the preparation of diborane is also given. Okay, okay, treatment of gaseous boron trifluoride. What's the formula for boron trifluoride? Boron means B, then fluoride means F, trifluoride, so BF3, that is boron trifluoride. When boron trifluoride is treated with sodium hydride, the formula for sodium hydride is NaH. That is the formula for sodium hydride. Okay, so when boron trifluoride is treated with sodium hydride around 450 Kelvin, it gives diborane. What it is giving? It's giving diborane. Okay, to prevent subsequent pyrolysis, the product diborane is trapped immediately. So if the prepared diborane is not trapped out, subsequent pyrolysis means the compound can be decomposed on heating. So to prevent that, the formed compound will be trapped out immediately. The equation is given here: BF3 plus NaH. BF3 boron trifluoride, then NaH means sodium hydride. At an around the temperature of 450 Kelvin, it can form diborane B2H6 along with the formation of sodium fluoride NaF. Okay, so this is the preparation of diborane. BF3 when reacting with sodium hydride around 450 Kelvin, we will be getting diborane and sodium fluoride. The next chemical property is formation of boron trihalides. The example for trihalides are BCl3, BF3 and so on. Okay, so that we are going to prepare. When boron combines with halogens, you know, fluorine, chlorine, bromine and iodine, and the reaction must be carried out at a higher temperature. At that time only there will be a formation of boron trihalides. Okay, the equation is given here: two molecules of boron reacting with two atoms of boron reacting with 3 molecules of halogens. At that time the resultant compound will be boron trihalide BX3. Generally it's given BX3. Okay, so boron trihalides preparation over, and then preparation of boron nitride. First we have to remember the formula for boron nitride. The formula for boron nitride is Bn. What's the formula? Bn. Okay, so when boron is allowed to burn with dinitrogen means N2. It's very simple. Okay, when boron is allowed to burn with dinitrogen at a higher temperature, here also the temperature must be maintained at a higher value. At that time there will be a formation of boron nitride. So what will be formed? Boron nitride will be formed. Okay, so the equation is 2 atoms of boron, no? So 2B plus dinitrogen N2. At a higher temperature it will give 2 molecules of boron nitride, 2 molecules of Bn. Bn is the formula for boron nitride. So with this, the formation of boron nitride is over. And then formation of oxides. Oxides means we know any metal reacting with oxygen means that will be called as oxides. So that we are going to see. What's the formula for boron? B is the formula for boron. When boron is heated with oxygen at around 90 Kelvin, the temperature is high here also. Okay, because we have seen it's less reactive, but it shows high reactivity at higher temperature. So when boron is heated with oxygen at around 900 Kelvin, it can form boron oxides. So 4 atoms of boron, 4B plus 3O2 gives B2O3. Okay, okay, formation of oxides completed. The next reaction with acids and alkali. Acids and alkali, okay. Examples for acids: HCl, H2SO4, HNO3, and so on. So we are going to see how boron reacts with the acids and also the alkalis. Alkalis are water soluble bases are called as alkalis. Okay, so first, boron shows no reactivity with halo acids. What are called as halo acids? HCl, HBr, HI. Those things are called as halo acids. So hydrogen with halogens, that is called as halo acids. This molecule, this boron atom, does not react with halo acids. It can react with H2SO4, HNO3 and remaining acids. Okay. So at that time, when boron react with H2SO4, the resultant compound is boric acid. Even when boron react with nitric acid, the resultant compound will be boric acid. And the formula for boric acid is H3BO3. Okay, va? Okay, so 2B plus 3H2SO4 gives 2H3BO3 plus 3SO2. Likewise, boron plus 3HNO3 gives H3BO3 plus 3NO2. Okay, the resultant compounds are boric acid. Then reaction with alkali. The simplest alkali we have taken is sodium hydroxide. 2 atoms of boron react with 6 molecules of sodium hydroxide. The resultant compound will be sodium borate. The formula for sodium borate is Na3BO3. Okay, so Na3BO3 with the liberation of 3 molecules of hydrogen. I think with this, the chemical properties of boron is over. Okay, so what are the properties we have seen for boron? The first property is formation of metal borides. When boron react with metals, the resultant compound is called as boride. And next we saw reduction of boron trihalides. When boron trihalides are treated with particular metal, the BCl3 will be reduced. That is the second one we saw. And then formation of hydrides. Hydrides cannot be prepared directly. In an indirect way we can prepare, and also the preparation of diboron is given, and preparation of boron trihalides, and formation of boron nitride, formation of oxides we saw. Then finally reaction with acids and alkali. Then finally we are going to see the uses of boron, how boron is useful in our common life. Okay, va? First, boron has the capacity to absorb neutrons. Okay, so you all may know about the working of nuclear reactors. Okay, so when a particular atom is bombarded with high speed neutrons, it will be scattered. So from that energy will be electricity will be produced. Okay, va? So the boron has higher capacity to absorb the neutrons, so that it is used as a moderator in the nuclear power reactor. Then second one, amorphous boron is used as a fuel igniter. Fuel igniter means to start the burning process. What is used? This amorphous boron is used. Okay, va? And boron is essential for the cell wall of plants. It is present where? In the cell wall of plants, boron is present. And then compounds of boron have many applications. For example, in eye drops it is used, in antiseptics, in washing powders, Okay, in all these boron is used, mainly boric acid and borax. And in the manufacture of Pyrex glass, boric oxide is used. For Pyrex glass preparation, what is used? Boric oxide is used. So these are the uses of boron. Okay, students, go through this video and learn well. Thank you.